Right, hi guys. We're going to talk today about, or I'm going to talk now about, well, stationary points. Okay, so you'll see stationary points as a phrase, and it might be also referred to as a turning point, which is important to recognise. But what does it mean? Well, it basically means, and it links into the work you've been doing on completing the square. It basically means like a maximum or a minimum. So here's a curve. I'm going to draw a couple of quadratics really, but here's a quadratic what's got a maximum. So this point here, you call the turning point there. Oh, it's a bit little that. That's the turning point there, that point. So the maximum of it. Or you could have, again, I'll draw a quadratic with a minimum. I suppose that's a bit like a quadratic, yeah, with a minimum. And there's your minimum point there. And the point about these is, and why it links to what we've been talking about, is because at these points, the gradient is 0. So look here to the left. The gradient is positive. It's going uphill. And over on the right, the gradient is negative. It's going downhill. So in the middle there, at that very point, at that maximum, the gradient is 0. I'm going to try and draw the tangents. Yeah, that'll do. Okay, so there's my tangent there. And the tangent is, well, it's a horizontal line. So it's got gradient 0. Same with this one here. I'll draw this. Might not draw it very successfully. Yeah, okay. So there's that tangent. And again, it's horizontal. It's got gradient 0. So, you know, when we think about the gradient of the tangent like we've been doing, what we talk about, they were talking about duality x. So duality x is 0 at this point here. Duality x is 0 at that point. Now, I just want to show you another type of stationary point. It's neither a maximum, so it doesn't look like this, nor a minimum. It doesn't look like this either. I'll show you. I'll draw it, and it looks like this. So it looks like I'm going to draw a maximum, and then, well, I don't. Okay, it goes like that, and I haven't drawn that very well, but I'm sure you can see the gradient's positive, 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 but we're getting shallower, and then it starts getting steeper again, and in the middle there, there's going to be a point where the gradient is 0, and it's funny thing to draw a tangent here, because this tangent's going to actually cross the curve. But if it did draw that tangent there like that, again, it's got gradient 0, and this type of stationary point, we call a point of inflection. So this is our maximum. This is our minimum. And this is what we call a point of inflection. And it's neither a maximum nor a minimum. It doesn't have to look like what I've drawn. It could go the other way. It could go like down, across, and then down. But either way, it's you know, it's neither a maximum nor a minimum. So what is the point? The point is at all these stationary points, at all these what we could call turning points, the gradient is 0. So therefore, duality x is 0. And that's the crucial thing. So if the gradient is 0, then that means duality x equals 0. And that's how we find out where they are. So what do you do? If I wanted to find out what the coordinates were at this point, I would firstly find duality x. And then once I've found the expression for duality x, I would then, well, I'd solve the equation duality x equals 0, because I find out where duality x equals 0. That would tell me what the values for x are. And then I would use those values for x to work out what the y coordinates are. And that's exactly what you do. So if I was going to write myself like a method, I would say, firstly, find duality x. Okay. We've been doing that. We know how to do that. Okay. Right. Next, solve the equation duality x equals 0. Now, what do I mean there? I mean, solve the equation where this is an expression. Think of the expressions we have in duality x so far, stuff like, I don't know, 3x squared plus 2x plus 1. Okay, well, that's not going to be 0, is it? But you know, stuff like that. Okay, so they're being quite complicated, but they've all been expressions that, you know, there's no reason we couldn't solve them. So solve that equation, and that will give us the value for x. So it gives us values for x. In other words, the 4x. In other words, the x coordinates, okay? And then finally then, a little bit like what we've done recently, sub the values for x into the expression for y to find the y coordinates. Okay, and that's it. That's what you do. And well, let's do an example. Okay, so I've got an example here. Right, and it's not dead hard this, but let's see what the situation is. Okay, so there's the question there. Right, it says find the coordinates of the turning point on the curve. It says of the curve y equals x to the power 4 minus 32x. Okay, well let's do it then. So firstly, dy by dx. So dy by dx equals, I'm going to differentiate this. What do we get? 4x cubed. Take away 32. All right. Now what? I want that to be 0. So 4x cubed minus 32 equals 0. So therefore, I'm going to write it like this: 4x cubed equals 32. So x cubed equals 8. So therefore, x equals 2. Okay, and that's it. Well, it's not it because that's the x coordinate, but that's all the hard work done. So if x is 2, y equals 2 to the power 4. Take away 32 times 2. So what's that? 16 take away 64, so minus 48. So what's the coordinates then? Let's answer the question. The coordinates are 2 minus 48, and that's it. That's the end of the question. So find the coordinates of the turning point of that curve. dy by dx, there's the expression there. Then if I say dy by dx equals 0, then I'll go through it until I find out what the value for x is. And then finally sub that value of x into the y expression to work out the y coordinate, and there I have the coordinates of that turning point. So there's one turning point on that curve, and that's its coordinates. I think this looks like this curve. It just looks like a grander quadratic graph, maybe a little bit fatter. That's what it looks like. But it's got one turning point, just like a quadratic graph has. Right. Okay. Let's do another question. Where is it? Right. Here we go. Okay, so find the coordinates of the stationary points of the curve. And do you know what? I think this might be stationary points. I think I might have missed off the S there when I was writing it. Of the curve, that there. Okay, so what then? I'm going to differentiate it. So dy by dx equals, well, what is it? 6x squared minus 30x. Add 24. Add 24. Right, okay, there's dy by dx. So then I want dy by dx to equal 0. So this equals 0. 6x squared, take away 30x, add 24 equals 0. Well, that's just a quadratic to solve. I don't really like the look of it, so I'm going to divide everything by 6. And notice really happily that everything does divide by 6. X squared, take away 5x, add 4 equals 0. I am much happier doing that because I can see that it factorizes. X take away 4, x take away 1 equals 0. So x equals 4. What? X equals 4 or x equals 1. There's me 2 values for x. And each of those gives me a stationary point. So I'm going to sub them into y and work out what the y coordinate is. So say I do the 1. So x equals 1, y equals 2. Take away 15, add 24, add 6. So what's that? I think that's 17. Okay. So my coordinate there is 117. Is that right? 32, 50. Yeah. Okay. Right. There we go. And same with x equals 4. I'm going to sub that in. So I've got y equals 2x cubed is 128. Do that on your calculator, you know. Minus 15x squared. Oh, what's that? 240 plus 24x plus 6. Okay. And what is that? I haven't even got my calculator. 128 and 102. What's that? 230. Take away 100, 240 minus 10. There we go. That wasn't too bad. Okay, so what's the coordinates? 4 minus 10. Now, that's pretty much it. That's pretty much all you need to do. But it's important, and I'll tell you why it's important, because when you're working out the maximum value, or the minimum value or whatever, so there's your curves there. Like this curve could represent like the speed of something of a car. You want to work out the maximum speed, so you want to work out where to have the x is 0, or it might be like the minimum cost in something, or think of formulas that you might see for volume and stuff, and you might find the minimum surface area or something like that. So it's all really, really important. The one thing I'm going to say, just as a little aside, is you want to know whether these points are a maximum or a minimum. Okay, and I'm just going to talk. I'm not going to go through this, but I'll talk about it just as something to say. Right, the difference between a maximum and a minimum is and I'm not really interested in this for now. Just these two is, if you look at these, both of them have got gradient 0, so both of them, the tangent is horizontal. But on a maximum, if you look a little bit to the left of the turning point, the gradient is positive, and to the right, the gradient is negative. So if you have a curve where that's true, then that must be a maximum. And on a minimum, the reverse is true. So a little bit to the left of that point, the gradient is negative, and a little bit to the right of that point, the gradient is positive. And that's what the difference is. So that's the difference between a maximum and a minimum. And can you imagine? I'm sure you can. What it would look like if a curve had both of them. Well, yeah. What would it look like if it had both? Well, it'd just be like, for example, a cubic. So cubic looks like that. Okay, and it's got a minimum here, and a maximum here, and a minimum here. And in fact, what we've just done, the question we've just done, was a cubic. Okay, let me get it. There we go. So it was a cubic. You can see that it's a cubic because it's got x cubed, and it had 2 turning points. We had 117 and 4 minus 10. Okay, so I presume one of them is going to be a minimum and one of them is going to be a maximum. And what you could do is you can find out what the gradient is. So when I say a little bit to the left of one, I mean a number like 0.9. So if I work out to have the x at 0.9, it'll tell me if it was positive or negative. And then to the right, what do I mean by that? I mean like 1.1. So if I work out to have the x when x is 1.1, then it finds out if it was positive or negative. And through that, I'd be able to find out whether it was a maximum or a minimum. Right, that's all I'm going to say. That's it. What I want you to do, though, is to do the questions that I'm setting you, and then that's it. So I hope you followed that okay, and obviously rewind it or whatever if you never, but and you know, try and follow what I've done. But what am I doing? Right, but well done for listening.